hello, Vamshi.
Hello.
Hello, everyone.
How are you doing today?
It's a pretty good day out here in California. How are y'all?
Good, good, good.
Pretty good,
So,
Vamshi.
yeah, so just a reminder for those of you at home joining in on chat, we have some subject matter experts in the chat to help you out with questions if you have anything about what we're talking about here. And if there's anything that we think everyone should know about, we'll bring that question or comment on screen so that you can see it and we'll talk about it. So, Vamshi, tell us what has just launched and why customers should pay attention to this.
Okay, so what has launched in AWS RoboMaker service recently is the ability for customers to add doors in indoor environments that they create with the WorldForge functionality. Just to give a sense of what the WorldForge functionality is, so the value proposition that customers get out of RoboMaker today and why they love it is because they get to simulate their robots and test it in virtual environments, just like how you have your video games. We have simulation engines with physics running on them so that they can evaluate how their robot is performing, so that they can minimize the bugs and issues that end customers get to see. The recent functionality that we've just provided is we've made it easier for our customers to test a lot more cases that they see with their robots. We kind of go for the indoor robot market segment, like a cleaning robot or something that you might have indoors. So with this ability, some of the common issues that if you've got an indoor robot, you might have seen, the robot gets stuck around doors, it kind of goes inside and locks itself out. We help them avoid these issues by able to test their code against it.
Excellent.
So robots at home. I guess a lot of folks have seen the Roombas and all those things. I had a few, and I know they were also always struggling with doors and rooms in general. So, but Vamshi, before we get into this exact details, let's actually explain to the audience what is RoboMaker. It sounds very cool. Like the term RoboMaker sounds amazing, but what is it?
Yeah, that's a good question. All right, so RoboMaker is the most complete cloud solution for you to simulate, test, and securely deploy code onto your robots. What does that mean? So your physical robots has got a lot of intelligence into it. It's a ton of code, multiple subsystems, different pieces of things doing different things. Developers and companies need the ability to test these pieces of code so that they can actually have a good experience for their end customers. So the first piece that we help them with is simulation. Okay. So basically what you do is you bring in a 3D virtual representation of the world, like a house, like a room. There's virtually no limit to what kind of environment you can bring in. And once you bring in this environment, you can write your code and test it against this virtual environment. So physics will be running in it. There's going to be sensors that's going to be giving you out data that is as close to the real world as you can code up. And with this ability, customers can then test their code against the data that's coming in this virtual environment, see if the robot is doing what they expect it to do, and if the functionality that they're wanting to build is present over there. And of course, the other side of things is we also help customers develop these code by providing IDEs and the ability by running some common software such as ROS and Gazebo. And at the end of the day, once you are done building this code, they will have to deploy this code onto the robot so that the robot ends up actually doing and implementing this code. So we have capabilities to securely push code from AWS onto the devices.
So in essence, this means that if I want to build, a robot that does something, instead of having to rely on physical space and the world to teach the robot or to test the robot or basically to test the software that's using the robot, I can provide it a virtual environment, a virtual world, basically for the robot to live in, right?
Absolutely. It's an excellent starting point and something that we strongly believe that robot companies, developers, and users of robot should inculcate into their everyday software processes.
Yeah, and what does RoboMaker actually? What can RoboMaker simulate? What all of these things can it do?
Okay, so RoboMaker can simulate pretty much anything that you require a robot to do. Say, for example, you've got a legged robot, you've got an arm robot that does pick and place, a mobile robot that goes from one location to another, a robot in an ocean. There's actually virtually no limit. You can bring in Gazebo, which is a 3D simulation engine. And as long as you build these assets into the simulation engine, RoboMaker helps you run physics and simulate those environments in.
There's a question here from a gentleman called Pecky ZG. I know this person. Well, at least he's welcome back to the stream, Pecky. Let's say I want to build a sailing robot. Is it possible to simulate the water and weather at sea and all of those things?
Definitely. There are tools within the simulation engine that help you simulate things like waves, help you simulate things like wind, and other aspects. Of course, it does require you to put in a little bit of effort to model it the way you want it. But these capabilities are present in the simulation engines for you to take advantage of.
Oh, awesome.
That's really cool. So it sounds like with a simulation environment, I'm able to get started a lot quicker. Is that true?
It is. It is.
Quicker and possibly cheaper. So that if someone from home maybe wants to start playing around with a robot or making something, they can create this simulation environment.
Good point. So that's precisely why AWS RoboMaker has the WorldForge service. Okay. So while simulation helps you get started quicker, there is still a base requirement that you build the assets for simulation. How the world looks like, what is the stuff that's there in it, what are the things that you actually care about. These are the things that customers have to, well, at least had to bring in themselves. But we've heard from our customers, this was actually a little bit of a pain for them because they need to bring in graphic designers, they need to bring in model designers that is not necessarily their core competency. So what we did a few months ago was released a functionality called WorldForge. I believe there's actually a segment on that in one of our earlier sessions. And in that, we let the customers create an indoor house environment with a couple of clicks of buttons. And they'll be able to get virtually unlimited number of permutations and combinations to test their code against.
Cool.
And I mean, there's also a question here from, unfortunately, due to LinkedIn settings, from LinkedIn user. Hello. How about simulations for search and rescue ops? I mean, this is a very specific situation, but like.
No, that's a good question because it ties into the use case of why people would use robots.
Yeah.
I can speak with a real world example that, mind you, is not tied to AWS RoboMaker, but ties to simulation in general. The DARPA challenge, I believe, a couple of years ago, actually, it's more than a couple of years ago, back when I was right out of CMU, they had a test scenario where you had the Fukushima disaster and you had to send in a robot to open up and close the walls in dangerous environments where, it's very difficult for humans to get to. They actually ran these simulations and brought up their code before eventually testing the code and doing competition on real world robots. So you can definitely use simulation for these scenarios. You can also use such scenarios for training purposes. There's definitely value over there.
Yeah, these are some really great questions and ways and reasons to be using both robots and the simulation environments.
And robots are just cool.
Yes, exactly. So
before we continue, just Jenna. Yep. Hello, Pam. Hi. We just want to welcome Pam, our additional ASL interpreter. Welcome, Pam, and thank you very much.
Yes, thank you, Pam. Okay, so I'm curious. So it sounds like we've added the ability to simulate doors within indoor environment. So tell us a little bit more about who needs this functionality and why do they need it?
Yeah, I can show you while I'm talking through it.
Oh,
so
I will bring up your screen share. All right.
Sounds good. Yeah. So functionality, as I mentioned, the worlds that we create are for indoor robots. So typically, indoor vacuum cleaning robots are the biggest benefactors of this tool. But that said, there's nothing stopping from any indoor robot building company to take advantage of these situations. I think this is going to be a common issue that pretty much any robot that resides in a house is going to see.
Right.
But the functionality that we've built is in the work section.
I think
Let me just create a template with.
Okay, good.
Were you saying something?
You were dropping in and out a bit, so your internet was a bit iffy. So please continue. You're talking.
Got it. Am I back now? All right,
Yep.
good. So we give configuration and capability for our customers to define the kind of indoor environment that they want to build. So let me just pick a template and say, for example, I want to build a one-bedroom apartment. That's kind of the one that I stay in. And the RoboMaker service provides a ton of capability for you to define how you want to define your world. You can choose the general area of your bedrooms, the living rooms. These are more of your preferences. We will randomize things behind the scenes so that we give you variety when you're testing your robots against. But the feature that we've added in this tiny section over here, but adds a ton of value to our customers, is doors.
Okay.
Here I can go in and say, let me customize the doors that I can put in my indoor environment. So let me just go ahead and say my doors. I'm going to have doors in all rooms. I'm going to have them hinged. And what is the status of it? I'm going to randomize it so that some of them are closed, some of them are open, and some of them are in different configurations. I'm going to save that, and then I'm going to go ahead and generate the worlds. So this is the section which actually provides the biggest value for our customers when it comes to using WorldForge. I can tell them how many kinds of permutations and combinations that I want. So I can tell them, give me 5 different floor plans and give me a variation of furniture and components within the floor plan, to this time. So I can generate like 10 worlds in a matter of a couple of minutes. So as I hit the generated worlds, it's going to run things serverless in the backend, and you're going to end up with a few worlds that are available to you. This takes just a minute. So let me go back to the generation job.
Yeah, well, that is the thing. So this in essence means that you do not have to model each world. It's sort of automatically generated, procedurally generated for any number of jobs you decide, right?
Absolutely. Yeah, this is the key aspect where customer comes in and says, okay, I have a physical area, I've tested my robot in it, which you really can't avoid because at the end you do need to do physical testing, but it doesn't catch everything. Yeah. So what you'll get to do is, I put my robot in a certain customer's house and it failed. Catch the logs, grab some data. You may or may not be able to grab the data depending on if you've set the right fidelity of logging, and then repeat the scenario so that you can fix it, deploy it, and hope that it doesn't break with a new scenario in the 3rd house or the 4th house, and so on and so forth. What this functionality allows is now you'll be able to set things up, get 10 different wells. You can see that 5 of them have already popped up on my screen. And if I'll have to wait for all 5 of them. But you can see that in my first floor plan variation, there's different combination of furniture, there's different settings. This kind of gives a really good variety for our customers to test different indoor worlds.
Vamshi, can you just zoom in a bit on your browser so we can see this in a bit larger form? Perfect. That's much better. That's much better. So good. So okay, excellent. So it basically distributes this furniture randomly. Well, not randomly, with some rules, I guess. But it creates these different layouts of houses, and this is what you call WorldForge, right? WorldForge creates these rooms.
Yes, excellent. And you can see within the worlds, this door is partially open, this one's fully open, there's one over here that's fully closed. So you get different scenarios for customers to test out almost immediately.
this takes me back to The Sims. I kind of
Yeah.
I see myself playing Sims on this. It's like and I need to just nerd out a bit. Does it actually? How does it know that the sofa needs to go next to X, or does it do it truly randomly, or does it have a couple of rules that a sofa can only be against the wall and things like that?
Coffee tables in front of the sofa.
Exactly. Yeah.
Good question. I don't know the answer fully because that might be part of the secret sauce and
Okay.
like the cool engineering stuff that I'm not familiar with. That said, most of the worlds that I create seem to be sensible. Obviously, you're going to have one or two little outliers that is going to show up and say, why does the bed look in the middle of the living room? But apart from that, for most of the worlds that I create, like you can see on the screen,
Right.
it seems to be in a sensible permutation and combination that customer can actually use pretty much immediately.
Gotcha. And can you scroll up a bit? I really want to see if the layout of the sorry. Okay, it's not the same. I thought the shape of the apartment was the same in all places. It's just 2x2 are the same. Okay, awesome.
Yeah, we've given this configuration. We've told the service, give me 5 different floor plans with 2 permutations of furniture each. So what you see over here is, in fact, I set it up very well accidentally.
Yeah.
These 2 are the same floor plan but different furniture combination. And then here you get a whole different floor plan with a different set of permutation and combination of furniture within it.
Yeah. And we even have people commenting Sims. So there you go. Yes,
Yeah.
it is The Sims. It does remind me of The Sims.
I
Go
just
ahead.
want to say there's one question in chat about being able to use. We talked a little bit about search and rescue before, but is there the ability to upload like a blueprint of a building into this, or so that they can simulate through that?
Not yet in AWS RoboMaker, but we are always listening to customers. If
Yeah.
you've got a use case that you think would be interesting, feel free to reach us out.
Yeah, definitely.
Yeah, and yeah, chat. Please let us know. Do you have robots at home?
Yeah.
These things are kind of getting more approachable, more affordable. So robots are kind of becoming part of our lives, from the thing that vacuums your apartment to even mopping the floor now. I think I've seen those that mop the floor, and the ones that actually mow your garden. But I think RoboMaker does a lot more than just that, right? We talked about search and rescue. We talked about those things that can be, kind of very important on this one. So let us know. Do you have a robot at home, and do you agree with it, or does it do a good job, right? So yeah, awesome. So tell us a bit about these doors. Why is it so important that we have doors in World Forge? And
Good.
Yeah.
Did you have a follow-up, or did you want me to answer this?
I'll follow up later on. So just
Got it. Yeah. So the question boils down to, while we are providing simulated worlds to our customers, what's the next biggest problem that we can solve? So with the first WorldForge functionality, we've tried to solve the problem of, well, asset creation is a big trouble for me. It's expensive. It requires special skills. What can you do for me over there? So we brought in WorldForge and the ability to create worlds. The first version of WorldForge had, there were no doors. Any connection between 2 rooms, it was open, and the robot could go through that easily, which still provided a ton of value because it enabled the customer to test out 90% of the tests that they had.
Right.
But some of the situations that these indoor robots face, those could not be satisfied with the criteria that there was no door. For example, like I mentioned in the beginning, it gets stuck in a room. The room was partially open, so it kind of went inside. It accidentally pushed the door so that it closed itself, and now it's trapped, and it needs to call its master to come in and open it up. Or it opened up a door and it has a whole new space, so it has to go and clean it or move within it if it's not a cleaning robot. But it still has to be smart enough that it knows, okay, I need X amount of charge so that I can actually go back to my charge station and figure it out. So these sort of test cases were also important to our customers because it affects their end users' experience. And AWS, that's what we care about the most. So we worked on enabling our customers to get this functionality so that they can improve their testing, thereby provide a lot better functionality to their customers.
Awesome. I would like to address a couple of questions from the audience because we have a couple of very interesting questions here, right? So Narmada asks, how about simulation of kids, pets, or moving parts, right? I'm yet to see an apartment which is completely still. So is there a way, oh, wait a second, let me put myself down so we can see Pam. Hi, Pam. Is there a way so we can have some sort of a moving element in an apartment that can kind of be dynamic to help out RoboMaker?
Yes, so definitely you can simulate it. So simulation is one of those engines where you can pretty much do everything you put your heart to. It's a question of at what point do you see diminishing returns and if the effort is worth the reward. Moving parts that are simple enough, like boxes falling, fan moving around, things rolling on the floor, these are simpler objects for which your modeling will be a lot more easier to do. So you can get started with it right away. Kids, pets, humans, cars, there are already some of these models that are available in simulation engines that you can use, as a drop-in. But if you need to build something that is really custom and what you have is not something that you need, that will require you to put some effort in there. So yes, you can do it. Say, for example, you're going to run hundreds of thousands of simulations. It's definitely worth putting in the effort. If you've got a very niche project where you're probably not going to simulate this very specific case of kids and pets, probably not.
Okay, cool. And there's another question here as well. Oh, I missed it. I think, yeah, okay. So it's from Vamshi Krishna. Assume the concept machine learning or training or image processing is used in creation of the simulation, or is it all just predefined?
I can't talk about what was used to build this, but it's a very interesting point that, he's got my name, Vamshi Krishna has set up. You can leverage the data from these simulation words to build on top of your machine learning algorithms. I think that opens up a ton of possibilities. As I was saying, you can get data from these simulation engines, and we use that to help our customers, test their algorithms and other aspects. Some parts of these algorithms can be AI and ML related. You can take a realistic rendering simulation engine, get the data from it, and from there on, you can see if you can run it through your machine learning algorithm to improve training, test your AI ML algorithms and see if they perform the way you want to, or overall reduce cost and complexity so that you get to your end result quicker.
Awesome. Well, cool. Thank you. Make sure to keep on asking us questions as well.
All right. So one of my favorite questions to ask during this show is, if we just launched this feature, what were customers doing before we launched this feature? How are they solving this problem? I have an idea, and it sounds like it could be time-consuming and expensive to do.
Well, that's a good question. I think if we step back a teeny bit and say there was no simulation whatsoever, the approach that you'd go about for testing is, let me build a test environment where I can have an indoor house, and I'm going to have an operator physically come in and set the robot over there, pull in the code over there, get it to the state that I want, and run test case after test case serially.
In a physical environment.
Exactly. It can be cumbersome. Of course, as I've mentioned, you definitely should do that testing before you ship out your product. But most of the bugs, or 80% of the smaller bugs, they can actually be caught right before the QA. So that's what they used to do beforehand. Now, if you can imagine, you've got in simulation world, you've implemented batch CI/CD, you're able to run a ton of tests, you're able to catch those bugs. But like you specifically asked, there is no door available in your simulation engine. Well, now you've created maybe like 10, 20, or depending on how a customer and what's their threshold, or tests, now you can't avoid running it physically. Or the alternative is you kind of have to manually add these things into your simulation engine with your designers, 3D experts, or bring in those models and put in the effort to do it and lose a bit of flexibility that you get with AWS RoboMaker. So either you kind of have to do the physical testing back again, which can be cumbersome, or you have to put a lot more effort into simulation area so that you can manually edit these models, bring in the functionality, and put the extra effort to test them.
Okay, so you know, we're talking about the cloud, right? We like to talk about scale. Everything in the cloud needs to be 100x. Yes. And of course, you know, doing things manually with robots by building your little prototype to run around your room is not scalable. RoboMaker and WorldForge seems to be scalable. How scalable? What are we talking about here? We've seen 10 things happening here. What if I want 10,000?
You can, absolutely.
Okay.
I mean, we've got some soft limits and hard limits that you'll probably have to check out and verify that you're good with that. But that's the beauty of AWS. You've got virtually unlimited amount of compute that the customer needs on a realistic use case basis. That's also, I think, a key point that will come up later during our conversation and the demo.
Okay.
If you are doing this simulation on your developer laptop, you're still compute limited, which means that even though you can virtually run the test and you can probably speed it up with a beefier laptop, you couldn't test 10 different tests at the same time. You couldn't parallelize it. You kind of have to wait for one another, or when you parallelize it to 2 or 3 tops, you'd still have to take a hit at the compute that is available. But because of the amount of compute and the configuration that's available with AWS now, with a single code change that a developer makes, you can spin off hundreds of tests in parallel, or you can limit it to how many ever you want. The biggest use case that one of our customer uses that I really like is iRobot has a CI/CD setup where they have a bunch of developers, robotic developers pushing code. And every time they make a code change, they run a bunch of tests in RoboMaker. And every day that they push code together, they run an even bigger bunch of tests that the developers can have access to the results first thing in the morning the next day. The beauty of that is you lose very little time to figure out where you need to improve, what's the bug is, and how you can give the best possible experience to your end customer.
I can't imagine doing CI/CD with robots for a physical environment. Like that just isn't even. Yeah.
Yeah, it's fun to think about that, like like CI/CD for robots, and I love the term that you use, robotic developers. I'm not sure if that's an offensive term or not, but it kind of makes me want to be a robot developer in this case.
I should use that better. That's a much better one.
Robot developer. Yeah, I think that's very, very cool, right? And here's a question from Jarno. Jarno asks, what's the added bonus for parallel rendering, right, for these models? And this also brings me to a question: is when you are doing this massive testing against 10,000 simulations, you get something out of it, right? You get some data, you get something. What does that look like? And what do we do with it?
Good question. So the question really is, what does the customer want to end up do with it? And what we've learned after talking to them is they'd like to specifically focus on scenarios that tests fail, right? And when the tests fail, what do? Right. You let me know that it has failed. You provide me the fidelity of information and logging that is available so that I can act on it. For this reason, one of the other functionality that we released last year was, or I think earlier in the year, I forget which one, was S3 uploads that we try to do as securely as we can and as reliably as we can. Basically, the customer can define, these are the logs that I care about. This is the information that I care about for my simulation, so that I can get actionable data for me to figure out where the bug is. And RoboMaker behind the scenes takes care of uploading all that information to the cloud. So along with the simulation aspects, we do try to make it easy so that customers have a good experience to have to act on what their end goal is.
Yeah. Okay. Makes a lot of sense. Jarno, thank you very much for your question. We hope we answered the question you gave us. Right. Okay. Cool. So I think kind of like we may have mentioned this, but let's try to make it a bit clearer, right? What is the ultimate end value for customers in this case? I'm not talking about just robot developers, but the people who will end up using those robots.
Oh, yeah. So whenever you purchase a product as the end customer, you'd like to get value out of it, and you'd like to get value out of it reliably. Now, if we as AWS make it easier for our customers to build, functionality and deploy code to their robots better, now you've just made it easier for an entire market segment to think about other use cases. The most popular ones that has already gained acceptance is, indoor cleaning robots. But there's nothing stopping us from thinking about humanoid robots, or robots for helping elderly, or robot that cooks in my kitchen, or robot that cleans my dishes and folds my clothes, which is something that I'd really like to avoid, but I can't.
What about the Jetson robot? What was her name?
What's her name?
Alice?
Yeah.
Yeah. So
something with Alice. Anyways.
So what I would say RoboMaker does is it opens up the ability for, people who are entrepreneurial, or who have a need, or who'd like to build a robot, to kind of work on it and make it easier for them to get them to market. And not only get them to market, but implement it in a production environment and do it the right way at scale.
But okay, so I need to tell something to the chat. Chat, have you seen this wonderful thing we do at AWS called Deep Racer, right? The little toy car that drives itself around the track, and you can go into tournaments and win prizes and all the fun stuff, right? All with the power of machine learning. Vamshi, tell me, does it use RoboMaker in any way?
Well, good question. I'll have to refresh my memory, but as of last year, all Deep Racer simulations were running on RoboMaker.
Exactly. So when you train your Deep Racer little car, it actually uses RoboMaker for all of that, right? It generates this virtual track. It generates all of these things, simulates the frictions and the forces and all the fun things that your car needed to do. Because here's the thing. When I first saw Deep Racer and they told me, oh, you have to, train a model so it will drive around. And in my head was like, does it really need to drive around my house? Like, to train itself? Like, how much time do I have to charge the battery? It's going to take a long, long time. But no, it's actually running in RoboMaker. So, yeah. That's the first time I heard of RoboMaker, actually. So, yeah. Cool. Then, Vamshi, do you have... You told us you're going to show us some demo, right? So we're gonna see something more, right? So I suggest I actually move the screen away right now, but I suggest that we kind of go into that demo.
Definitely.
Okay. So you tell me when can I bring the screen up? Can I do it now?
Right now. I mean, we can show the customer how I set it up.
Awesome. Good.
So you're seeing a bunch of text. This is kind of me doing a little bit of homework so that the setup comes up easily. But basically what I'm doing over here is making an API call called Batch API. That's actually my favorite part of RoboMaker that helps you run parallel simulations.
But right? Vamshi, tell us first, before you do anything, tell us what are you going to show us today?
Good point. So what I'm doing over here is stepping back a little bit further. So what you need to do to get a simulation going on in RoboMaker is first you need to have an application, which is what does your code actually do? You need a code that says, I need the camera data, I need the sensor data, and I'm going to give you a plan. You package all of this robot application up, and you send it to AWS to create a robot application. That's kind of what eventually, once the tests are passed, is going to be deployed onto your robot. Once you provide this package, you then have a simulation application, which is all your virtual part of your stack. How do you interact with the virtual data? How do you actually set up this virtual environment so that you can start things in order? And once you have that data, what do you need to do in order that? You provide that. We enable bringing in connecting the WorldForge worlds that you've created directly to the simulation application so that customer doesn't have to worry about it. These are the base requirements. Once you do this, the rest is you setting up configuration, parameters, things that enable you to, provide how much compute and cost it's going to cost you to do this, how much parallelization you want to provide, and all that stuff. So what's happening in the few bunch of shell scripts that I'm doing over here is I've already got a generation job which, as you've seen, is a bunch of worlds that I created. I have set up a simulation application and an IAM role. So the application that we need to run in the background and the role with which the permissions it should take. And then the rest of it is kick off a bunch of parallel simulations for me to run a bunch of robots in different worlds.
Okay. Let's see how it works. And it's all API driven, right? It's all just an API call away.
Everything is API driven in what I've shown you. We do provide some capability for you to interact with it on the console. It gives a better user experience when you're just getting started with it and you want visual representation. But let me zoom out a bit. Okay, so we see a bunch of simulation jobs that are preparing. What's happening behind the scenes is I've kicked off what is called a batch simulation job, which will kind of queue the amount of parallel simulations that you want to run one after another. You can see that it's in progress. And there are 5 pending and 5 that are preparing. I've asked it to limit it to 5 simulations at a time, which is the reason why it's pending, and it's going to ensure that it holds the simulations at that stage. And in the simulation job, it's going to do a little bit of stuff in the background where it's going to pull in the simulation application, set the environment, and run the simulation for you. It's going to take a minute or so. So in the meantime, if you've got any questions, I'm happy to answer those.
Yeah, so put the questions in chat, by the way. So yeah, if you have any.
There you go. We have at least one running.
Okay, that's good. We have a couple.
I'm sorry, did you have a question?
So I may have some questions here. So would these things also be applicable in automotive as well? Right. So when we talk about automotive, and I know cars are not robots, but when it comes to automotive, would RoboMaker be part of that somehow?
Well, I can speak on a simulation level because we take feedback from customers and we can always improve our product. But simulation has a play in, in general. I would actually disagree with the statement that vehicles are not robots. I would say a Tesla or a Google autonomous car, or pretty much the entire autonomous vehicle section that's going on, in my head, they've got the same challenges as robots. You need to perceive the world, you need to have sensors, you need to act on it, and then you need to act and control it the way you want it to. So definitely there is a play for simulation in autonomous vehicles and other industries. And I think, I'll pause with that.
Okay, yeah, fair point, yeah. So what is happening right now? So have our simulations kicked off?
They have kicked off. What's happening is another tab has popped up, which I recognize is not pointing to the StreamYard. So I am copy pasting the URL so that you can see it. So there's a little bit of manual process involved right now.
So if I understand this correctly, by kicking off a batch of simulations, we are able to simulate different environments based on different permutations. So in the case of this new feature, we've added in doors. So we can do open, closed, partially open, those 3 different permutations. And then in addition, other types of physical features within the room can be toggled on or off or visible or not. Am I summarizing this correctly?
You summarized it very well. There's a couple of points that I should have added on top of it. Not only do you get the capability to, simulate different combinations of door positions, you can also affect it at runtime. So you can have code that says, I want the robot to close at a certain time, open at a certain time, and give that programmatic ability for customers to affect with. Can you see my screen and a virtual environment on which a tiny little robot should be driving on the top right?
Yeah, can you bump the font in the browser?
Just zoom in a bit, yeah.
Yeah, if that works.
I don't think it works. Let me switch to this view, which is a better representation.
Yeah. Oh, this looks much better, yeah. Oh, wow.
Yeah. So what's happening
what
over
are we
here
seeing
is
here? Yeah.
the data from the robot simulation as it is running live. On the bottom left, that's the perception, that's the data from the camera of the robot, which it uses to figure out, where it is, how to plan, and other aspects. And what you're seeing on the right is visual representation of its main job. In this one, the sample thing that I've set up is just mapping of an area. When a customer brings in an indoor cleaning robot or an indoor robot, you want the robot to know where it's going and other aspects. So what you're seeing over here is the robot kind of moving around and mapping that entire area and things of that sort. This one seems to be a fairly successful simulation, so I'll probably switch to a different one that'll show an edge case. But in the set of worlds that I've created, I'm fairly confident. Let's see if that happens. But I'll probably be able to find a scenario where the robot's kind of stuck. And those are the kind of simulation environments that, customers can retry against, change code, and develop so that the robot tries not to do it in the real world.
I have a question for this one. So we're seeing the robot right now driving at robot speeds, right?
Yes.
Is there like a way to do a simulation really, really fast? Or does it actually have to be slow? Okay. Do we get something with it? Do we lose something with it fast?
Actually, in some cases, you gain stuff. So the trade-off is compute you want to use and what's the RTF, real-time factor, as it's called in simulations, at which your code runs. In many cases, you can actually improve the compute and the code runs faster. That will save you cost, because instead of running the instance for twice or thrice the time, now you get it done in like half the time or 25% of the time. So there's a little bit of a curve that you kind of have to optimize for. Or the other thing that you optimize for is straight up developer time. I need to run 10 tests. I don't want them to wait 10 minutes. I want the results in 2 minutes. Run all of them in parallel, run them with better instance capability, and you're going to get results quicker.
Awesome. Yeah, because that was like my main point here. We see a point of running this in parallel because you can run 10,000 parallel executions, and even if they need to do it in real time, you're still doing 10,000 of them in parallel. So hence you get things faster.
Yeah.
And I want to step back here for a second. So I am a developer, right? I am a robot developer. I want to build this wonderful robot. It's gonna walk through the apartment. It's gonna collect garbage, and I've delivered. I've developed the physical part. How do I get my code from this robot I built, and it's running on ROS, right? How do I get that code and the thing I've built into RoboMaker? How does that actually work?
Yeah, so there's two ways to do this. We have a few mechanisms for packaging your application. So we have a mechanism called Colcon bundling, which basically is a tool that will let you bring in your dependencies, your actual robot code, your simulation code, and all of that fun stuff, and puts it into a format that RoboMaker can help to set up and run the simulation for you. So that's actually the easiest way to do it right now. And once it's there on the cloud and it's compatible with the format that we've said, the rest of it can be a couple of clicks or a quick API call.
And would I need to model this specific robot that I've built in real life to be an equivalent in RoboMaker?
Yes. So the functions that your robot has to do is dependent on the sensors, the configuration, and other aspects. So you would have to do a bit of work to model your robot and make it appear both physically and in terms of physics to the simulation engine so that it can execute what it would do in kind of the real world. I just had that screen where the robot was nice and stuck, but it seems to have gone away. Let me try to find it again. But we definitely have a scenario which can show here's how your robot can get stuck, and this is a scenario that is repeatable. Now run your test again and again against this till you fix it and see if it works against your other environments.
Awesome. Awesome. And once this simulation is done, what is the artifact that we get out of that?
Yeah. So we can actually see a couple of simulations that have canceled. I've put a criteria that says if you are stuck more than 5 minutes, or if you've mapped for about an hour, you kind of close them so we can actually see them canceled. In the background, all the data that happened that corresponds to these simulations, we provide the ability to upload them onto S3, and RoboMaker behind the scenes takes care of doing all of that. So you can see over here, I've got what's called an upload configuration. Let me try to, yeah, it's a bunch of text for now, but map tells my logs, is the simulation engine over here. So my simulation logs and my robot logs, all three of them upon termination have now been uploaded onto S3, where I can have further processing on top of it for either my developer to download and work with it, or some automated process that kicks off as soon as you drop things into S3.
And these files are basically just some data points that it collected during the simulation.
Yeah, there's no limitation to the kind of file it can be. It's up to the customer. So I've got my image files, which is a PGM file, and my .log files. Customers can choose to put whatever they want.
Okay. Well, awesome. Vamshi, so how do we get people? I'm scrolling a thing here beneath us. How do we get the folks in the chat, folks watching this video? How do we get them to try out, to test out RoboMaker? How do we get that?
Well, I'm sure my colleagues on chat will be able to post a couple of links, but we've got a link for the blogs where you can see how AWS RoboMaker provides value. We've got this very specific sample application that I'm showing you. We've got a nice little blog around it that will help you replicate it and build on top of it. I think that would be a pretty good starting point for customers to start trying out to see all the value that you get.
Yeah, so check out the links in the blogs. And yeah, so I think RoboMaker is cool. If you want first-hand experience with RoboMaker without having to do anything in RoboMaker, I think AWS Deep Racer is one of the places you can start. At least see how it works. But I think one of the wonderful things about the RoboMaker and all the features from it, including WorldForge and this new feature that adds doors to it, it helps you become a robot developer, which is just amazing, right? So, Vamshi, thank you very much.